Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another GameMaker Studio 2 tutorial. In this tutorial, I'm going to be showing you guys how to create tile-based collisions and explaining some of the math behind that. By the end of the tutorial, you'll have a tile-based collision platformer like this that has smooth movement and perfectly working collisions. Quickly, I want to talk about some of the trade-offs that you get with tile-based collisions. First of all, you get major performance boosts. It's quite a bit faster to use a tile-based collision than it is to use the general method for finding collisions that I've taught in the past, the while loop with the place meeting. I also think this increases the workflow for creating levels because adding tiles, specifically in GameMaker Studio 2, is a lot faster than adding objects. It's really easy just to left click and drag and create a bunch of tiles, right click to remove them. It's nice. The drawbacks that I think are the strongest ones here is that it is a little bit more complex, so this is definitely not a tutorial for beginners, and collisions must be based on a grid that's a power of 2. So the first thing we need to talk about is the bounding box of an object. So every object has a bounding box. These values are indicated using the B box underscore and then either right, left, up, or let's see, bottom or top, right, left, bottom, or top. And it gives you the bounding box of that object. So basically, if our X position is 128, like we're showing here, and our origin is centered, then our bounding box position is going to be 160. And this is if we're using a square collision mask for our sprite. So our bounding box position will be 160, which is 32 pixels over since our total sprite width is 64. Binary math. This is important to understand for this tutorial. So first of all, let's look at our table up here at the top. I'm going to bring my mouse onto the screen here. We've got 16, 8, 4, 2, and 1. These are the placements for binary numbers. If you want to do the binary number 5, like this, you would need a 1 in the 4's place and a 1 in the 1's place, right? 4 plus 1 is 5. So this is what the binary number 5 looks like. Now the not binary operator, this operator takes a number and it knots all the bits. I guess it flips all the bits on that number. So if you can see right here from this example, if we start out with 5, like in our previous example, it's going to turn the 1 into a 0, the 0 into a 1, and the 1 into a 0, and flip those bits. We also need to understand the AND operator for binary numbers. This just takes, so for example, if we have our two inputs there, we've got 5, and then underneath that we have 6. It will basically go vertically and then return a 1 if both of the inputs had a 1 in that column. So you can see the column to the far right, we've got a 1 and a 0. Since there's not both 1s, it's going to return a 0. And then in the middle column, we have a 0 and a 1. Since there's not both 1s there as well, it's going to return a 0. And in the far left column, we do have two 1s, and so that will return a 1. How is this math useful? Well, when we're snapping to a grid, we can use the AND and the NOT operators in order to snap to a specific grid. It takes 2 steps, so let's look at both the steps here. First of all, we have our input, which is 11. And generally in your game, that's going to be the player's position. You know, like if they're at position X position 11. To decide what size of grid you want to snap to, you have to take the size of the grid you want to snap to and then subtract 1. So in this case, for this example, we're going to have a grid size of 4. And so we take that and we subtract 1. And that gives us the 3 that we have there. So the first step is to knot the 3. And you can see in step 1, we've got 3 in binary in that little table right there. We've got 0, 0, 1, 1. That's 3 in binary because we've got a 1 in the 2's place and a 1 in the 1's place. 2 plus 1 is 3. And we knot that, which gives us 1, 1, 0, 0. That value is going to be 12. Then we go to step 2, which is where we take the number that we got from step 1 and we AND it with our input, which is 11. So we've got 11 right there, and we're ANDing it. And you can see when we AND it, we're only left with our final answer right here, which is 1000, which is the binary value of 8. So we took our 11 and we snapped it to our position 8, which is, as you can see, if we're snapping to a grid of 4, 11 should snap down to the position 8. Now, if we wanted to change this, for example, if I'm going to bring my mouse on here, if, for example, this was a 1, that would make this value equal to 15. If we ANDed that with our 12 again, we would end up with 12 again, 1100, which would be exactly what we wanted, because 15 should snap down to 12. No matter what number this is, it doesn't matter what number this is. It could be as big as we want it. It's always going to snap to a multiple of 4 when we AND it with our knotted 3 here. So this will always work, and this is the basis for the collision system inside of our tile-based collisions. Okay, let's look at a quick example. So let's say we have our blue player object right here, and then the wall object that represents the tiles that we've added to the room. When we apply the horizontal force to the player, it then moves inside of the wall. We detect a collision, but there's a few things we know about the situation. Number one, our tiles are going to be aligned to a grid of 32 by 32 pixels. In this case, that's the size of the grid that I'm going to be using for this example. The edge of our wall will then be, let's say, at 128 pixels, which means we need the player, because our player's width is 32 by 32, to be at X position 94, and then will be moved flush with the wall. Our current player position is 102, so if we take that 102 and we AND it with the knotted version of 31, we know from what we've learned about binary math that that's going to snap it to the 32 by 32 grid. This is a simplified example of how this works. In the actual implementation of this, we are using the player's bounding boxes, which makes it a little bit trickier. And also, it's a little bit different for when you're colliding with a left wall or a top wall, because then you need to snap back but then move over by the width, by the snap amount, because that would snap you back into the wall and then move, because it always rounds down, right? So it'd snap you into the wall and then you'd move over by 32 pixels to be flush with the wall on the outside. So that's how this works. Let's get started. First, I'm going to create a new project inside of GameMaker Studio 2, and I'm going to do GameMaker language project. I'm just going to name this Tile Collision Tutorial. Once we're inside of our project, I'm going to right click on sprites and do create new. I'm going to name this S_player. I'm going to come in to edit the image, and I'm just going to make it kind of a blue-green color. Maybe this color. That looks good. Okay. I'm going to put our origin of this sprite in the center, but because of the way that I've designed this, it technically doesn't matter. You can do this you should be able to have any size of player and any origin. There is one thing that you need to keep in mind. We're going to be detecting collisions on the for the tiles on the top right corner and the top bottom corner, so we're only going to be checking 2 points. If your tiles, we're going to be creating the tiles right now, but if they're smaller than the player, you may have to check 3 points to detect a collision, or more, depending on how small your tiles are. But we're going to do the player and the tiles the same size, so then we only need to check the 2 points. Okay, once we've created the player object, we're going to duplicate that sprite. We're going to duplicate that sprite, and I'm going to rename this and name it S_tileset. I'm going to come in and edit this. I'm going to edit the image. Yeah, let's make it kind of a dark gray. So I'll make it a dark gray. And then we come out of the image, and we need to actually change the size here. And we're going to resize the canvas. We're going to say that the sprite is going to go to the right of the image. and we're going to give it a width of 128. We should be able to press apply, and what that does is it creates an empty space on next to our image right here. We're going to change our origin to top left for this, but that's going to create an empty space right here. Tile sets in GameMaker always need an empty space for the very first tile. Once we've done that, we're good to go. We need to create our tile set. I'm going to create a new tile set and name this T_collisions, and I'm going to assign the S tile set. Now you can see it defaults to a grid of 16 by 16. Obviously we want a grid of 64 by 64 because that's the size of our tile right here. And we're good to go. We've created our tile set. Okay, close that. I'm going to hit Control S to save the game real quick. By the way, I'm also doing this inside of the trial version of GameMaker Studio 2, so you should be able to use the trial version for this. Let's create a new script. Create script. I'm going to name this script Tile Collide at Points. Now this script is going to take two parameters. And this comment right here with the param, this is just a way to make the script show helper information whenever I call it. So this isn't required, but I do highly recommend it. We're going to pass in a tile map ID. I'll show you how to get that. And then we're going to pass in a point array. Point arrays, actually, and it could be multiple arrays. So first var tile map ID equals argument 0. Now you need to use the argument array. You can't use just argument 0 right here because we're going to be passing in an unknown amount of arguments. So because of that, we have to use the argument array to get the tile map ID. Now we're going to set up our found variable. And this is just going to be a Boolean. And we're going to say found equals false to indicate that we haven't found any yet. Now I'm going to create two temporary variables for the point arrays. Vector 2 x equals 0, var vector 2 y equals 1. That's just so that I can use the arrays as if they were vectors and use these variables to access the different positions of the array. So we're going to loop through the points and check for a tile. So say for var I equals 1. We're going to set it to 1 because we're looping through our arguments and we've already done the 0. And make sure you put a semicolon after that. We've already done the very first argument, the 0th argument, I guess. It's the first argument, but it has an index of 0. I is less than or equal to, well, let's just do I is less than argument count I plus plus. So this will loop through all of the remaining arguments, and we're going to say var point equals argument I. So that will get the current point that we're at. And then we're going to say found equals found, or tile map get at pixel. Now we need to pass in our tile map ID, tile map ID. And then we need to pass in an X position and a Y position. So we're going to do point vector 2 point vector 2y. So the other one's vector 2x and this one's vector 2y. And that'll give us the point we're checking for. Finally, we can just return found. Let's see. So found equals, let's see, return found. Okay, this script, this will allow us to check for a collision with a tile at a list of points. So we can check multiple points at one using only this one script and then return true or false based on whether or not we found a collision there. It's just used to simplify checking for a collision with a tile at multiple points, which is what we need to do. So once you've gotten that script done, we need to create one more script. This one's going to be the complicated one. That handles most of the logic for our collisions. So I'm going to rename this script move and contact tiles. So this will handle movement, will pass in a velocity vector, and it will also handle moving to a contact position with the tiles. I'm going to make this a little bit bigger. This is a pretty long script that we're going to write. This is the trickiest part of this. We're going to pass in a tile map ID. We're going to pass in a tile size. And we're going to pass in a velocity array, which will just contain two values, one for the horizontal velocity and one for the vertical velocity. We can use argument just 0 here. We don't have to use the array anymore, which is what you should do. Velocity is going to be argument 2. Then let's create our temporary variables again for the velocity array. Var vector 2, vector 2x equals 0. Var vector 2y equals 1. Let's handle horizontal collisions first. So I'm going to first move horizontally. So we're going to say x plus equals velocity vector 2x. So we'll get the x movement of our velocity vector and apply that to our x position. Now we're going to do collisions to the right. If velocity vector 2x is greater than 0, we're going to check to the right, else we're going to check to the left. So let's check to the right. Var tile right. We'll set that equal to tile collide at points. We'll pass in our tile map ID. And then we need our point arrays. So in GameMaker Studio 2, we can do an inline array like this. So we're going to pass in 2 of these. Our first one is going to be bbox right minus 1, comma, bbox top. So that's going to be the right edge and the top edge. So that's going to be the top right corner of our player. Then we're going to do bbox right minus 1, bbox bottom. So that's going to be the bottom right corner. I've found that I need to do -1 for bbox right and bbox bottom actually. So we need to do that over here, -1 on our bbox bottom. And the reason it seems is, I think, I haven't actually investigated the reason for this yet, but I'm pretty sure that it has to do with our sub-pixel movement. So because our character will be able to move smoothly and have an X position that is a sub-pixel value, we need to subtract 1 from those values. That's my best guess as to why. I'm not 100% sure on that one, but I know that this works. So then we check to see if we had a tile. So if tile right. So if we found a tile at either of those 2 points, then we're going to say x equals bbox right and this is a single and sign for the bitwise operator and, not tile size -1. Now, since we're actually colliding to the right, once we've done that, we're going to subtract we're going to do x minus equals b box right minus x. This gets the offset between our bounding box and our x position. This makes it so that no matter where your origin is on the sprite, this should still work because we're getting the offset and adjusting our position by that offset to make sure we're flush. Then we're going to get our velocity, and we're going to use the array accessor. What this will do is it will actually reference the original array passed into this. And the reason we need to do this is because we need to change the object's actual velocity array, not this temporary variable right here. So our player object is going to have a velocity array, and we want to access the actual one, and that's why we use this right here, because that will reference the actual one. Vector 2x equals 0. Now we're going to do the same thing for the left. It's very similar. Var tile left equals tile collide at points tile map ID. Then we're going to pass in two arrays again. And since this one's left, we just do bbox left, comma bbox top, bbox left, comma bbox bottom minus 1. That should check those 2 points. And it looks like I have an extra parentheses here, so I'm going to remove that. If tile left x equals bbox left and bitwise and not tile size minus 1. Now we're going to do x plus equals tile size plus x minus bbox left. Now if you remember from the example that I gave at the start, when we're colliding left, we need to add the tile size to make sure, because it always snaps down, so then we snap into the wall, and then we add the tile size to move back out of it. And there you go. Right and left collisions should be working. Let's do vertical collisions. So first we're going to move vertically. I'm going to give myself a little bit more room here. Y plus equals velocity vector 2y. We'll do vertical collisions if velocity vector 2y is greater than 0. We're moving down, else we're moving up. So we're going to do bottom collisions first. And we'll say var tile bottom equals tile collide at points tile map ID. Pass in our 2 points again. For the bottom, we're going to do bbox left, bbox, oops, I need to do it in the same array here, comma, bbox bottom minus 1. And we're going to do bbox right minus 1, comma, bbox left minus 1. If tile bottom and I've got a mistake somewhere in this. Var tile bottom. Oh, I've got an extra parentheses up here. Got to remove that. Okay. Y equals bbox bottom and not bbox or tile size. And make sure you do the correct not here. The bitwise not. Tile size minus 1. Y minus equals bbox bottom minus y. Velocity. Oops, and we forgot up here to do our velocity, but we'll just do this here real quick. Velocity at vector 2y equals 0. So set the velocity to 0. We need to copy this velocity right here and make sure we do it on our left collision as well. And if this looks kind of tricky to you, it is. Doing tile-based collisions is a little bit tricky. It's definitely not for beginners, but it's very powerful. Tile top. We're on our top collisions now. We're going to do equals tile collide at points tile map ID, and then our 2 points. And our point here is going to be B box left, B box top, and then our point here is going to be B box right -1 and B box top. Then we're going to say if tile top y equals B box top and not tile size -1. Make sure you have parentheses around the tile size -1 as well on all of them. Y plus equals tile size plus y minus B box top. And then we'll also do velocity here. Velocity y equals 0. Okay, you've done the hardest part. Save. Once you've saved, close out of this. We're going to create our tile or our player objects. So go into objects to create. Name this O_player. Add a create event, and we're going to initialize some variables in this create event. We'll say velocity. And I'm going to do an underscore at the end of my player's velocity just to differentiate it from the local velocity variables in my script. How you decide to do this is up to you. Some people do underscores before their local variables. I have decided to do it this way. And I'm going to set velocity equal to 0 and 0. So this is a velocity of 0 in the x position and in the y position, or horizontal and vertical, whatever you want to say. Gravity underscore, make sure you do the underscore, equals 1.5. Jump speed equals jump speed underscore equals 28. Max velocity underscore equals, I will have a horizontal max velocity of 8 and a vertical max velocity of 32. You do need to cap your velocity because if your player moves too fast, he will clip through the tiles. This is a problem in many types of collisions, however, so it's not specific to tile-based collisions, but you do need to have that. Can't move faster than 64 pixels at a time because that's our tile size. Acceleration equals 2.1. And the only reason I actually have it on 2.1 is because I was testing to make sure that sub-pixel acceleration would work. Now let's get the tile map ID. So we're going to say var. And in order to do this, actually we need to create our room first, or update our room. So go into rooms, double click on your room. I'm going to rename this r_1. I'm going to set my size here. Let's see, where's the room size? I'm going to set it to 640 by 360. We're going to create a new layer right here. So we have our layers, our instance layer, our background layer. We're going to create a tile layer. So come right here and click create new tile layer. I'm going to drag this layer to make sure it's under the instances layer. That means it'll be drawn behind the instances. I'm going to rename this layer collision tiles. Then I'm going to choose a tile set, T collisions, choose a tile here, and fill the room real quick. You can see how fast this is. That's one of the nice things about this system. I actually want to make the room 1280 by 720. I feel like that other size was too small, so we'll make it a little bigger. Okay, but you can still fill the room very quickly with your collisions. Just add some stuff here to test your collisions in multiple scenarios. Like this. Okay, that's good. Looks like a backwards fish. Then let's go back to our workspace up here at the top and click our player object. Let's set the sprite for the player to sPlayer. Now we can get the tile map ID. So var layer ID equals layer get ID. Now we have to pass in the same name that we named our tile layer. I named it collision tiles, right? Let's go back and check. Collision tiles, yep. So that's what we pass in. That will get the layer ID for that layer. And then we can say collision tile map ID underscore equals layer tile or tile map get ID layer ID. And this will get the tile map ID of our collision tiles. We'll need that later. Save. I'm going to add a step event now, and this will handle the movement logic. So step event. First we need to get the input. Var x input equals parentheses keyboard check vk right minus keyboard check vk left. Oops, got an extra parentheses there. Times acceleration. And that will just get our input for left and right and multiply it by the acceleration. Then we can do our vector variables here. Now I keep doing these as local variables. The reason I did them as local variables, especially in the scripts, is because I wanted the scripts to be able to be run independent of anything else. So technically you can copy and paste these scripts into any project and then immediately start using them. You should be able to use them. They don't have any dependencies is basically what I'm trying to say. And that's why I used local variables inside of them for the array and for the vector information. However, normally on a major project you might consider using macros or enums if you're going to use vectors in the same way I am right now. Just something to think about. And I want to make sure that I actually got the second one as 0. Okay, I did. It's easy to mess that up. So let's handle the horizontal movement right now. We'll just say velocity vector to x equals clamp velocity vector to x plus x input. So that's where we actually add our x input to our x velocity. Negative max velocity vector to x. Positive max velocity vector to x. And I'm just using the clamp to make sure that we can't move faster than our maximum velocity. I don't really need this room editor right now, just in the way. Okay, let's apply the friction. If x input equals 0, we know that we're not getting any input, so we can apply the friction. Velocity vector to x equals lerp. I'm just going to use linear interpolation for the friction. It seems to look nice enough. Velocity vector 2x. Our target value is 0, and the amount will be 20%, so 0.2. So this just applies a 20% friction to the velocity until we reach 0. Technically, we won't ever reach 0, but we'll reach close enough that it works. Then we're going to say gravity. We'll apply the gravity. Velocity vector 2y, because this is our vertical movement, plus equals gravity. And this is an interesting thing. This is one of the reasons why I actually like to use the underscore afterwards. I noticed that in GameMaker Studio 2, it prioritizes your instance variables over built-in variables. So you can see if I start typing in gravity, it will prioritize gravity, my gravity underscore instance variable over the built-in variable, which we do not want to use. So I like that. Of course, if you do an underscore beforehand, it also would prioritize it. But then you'd have to hold shift and do an underscore in order to get your autocomplete. I can just start typing gravity and hit enter. I don't have to hold shift. Anyway, it's kind of silly, but I like it that way. Okay, move and contact tiles. Move and contact tiles. We can pass in our collision, map ID, the tile size, which in this case is 64. You could store that in a macro if you wanted. That would be a good idea. And then we pass in our velocity, which is just velocity underscore. And we currently should have gravity and left and right movement already. Let's test it. We don't have jumping yet, but we'll test that in a second. Go back to your room, click on your instances layer, go to resources, drag your player into the room. We should be able to press play, and if we don't have any typos or anything, which we've written a lot of code, so very possible there's errors. But this seems to be working, so doesn't seem to be any errors. If you get errors, I'm actually going to provide the source as well in the description, so you can download that. You can download the source and compare to make sure that, and your error should tell you basically where the mistake is, so you can then compare with the actual source. Okay, so our gravity is working. One other thing, we're going to go into game options, main, and I'm going to set the room speed to 60 and press apply. Let's go back into our, navigate back up to our player's step event, and we're going to handle jumping now. So jumping. We're going to create an on ground variable, var on ground, and we're just going to do tile collide at points, collision tile map ID. We're going to pass in 2 points, just like we always do. These points are going to be B box left, B box bottom, and then over here, B box right -1, and B box bottom. Now you might be asking why I haven't subtracted 1 from bottom. Well, we're trying to check 1 pixel below the player, and beforehand we were always subtracting 1 from this. Well, now we're not. We're not subtracting 1. Makes it so it's like +1 there. Then we're going to say if on ground, else. So if we're on the ground, we want to handle jumping. We'll just say if keyboard check pressed VK up, velocity vector 2y equals negative jump speed. Else, I want to handle controlling jump height, which would be when we're in the air. We're going to say if keyboard check released VK up and velocity vector 2y is less than or equal to negative, negative parentheses jump speed divided by 3. Okay, that gets a little sneaky, but what we're basically doing is we want to say this is the minimum jump height right here, and we're going to allow the player to, as long as their velocity hasn't exceeded this, their jump height hasn't exceeded this, then we'll allow them to set it to this right here, and that's what we're going to do inside of here. We just say velocity vector to y equals negative jump speed divided by 3. Okay. Then we'll just run our game again, and we should be able to move around and jump. We can test all of our collisions and make sure they're working. And I apparently typed on ground incorrectly. Oh, I don't have an equals sign here. There we go. And we're not detecting a collision there correctly, apparently. So let's go in and fix that. Open up Move and Contact Tiles, and we just need to double check this. I'm going to do this to give us a little bit more room. We just need to double check these values to make sure that they were entered correctly. Okay, and you can see I made a silly mistake here inside of our vertical collisions. I'm checking for the left bounding box, and then the bottom, and then the right, and then the left. And that doesn't make any sense. This is for going down, so this should be B box bottom right here. -1. And I think that's it. We'll just need to double check, run our game again, and make sure that that was the only mistake. And that seems to be working now. So it is a little tricky to get all those in the correct spot and checking the correct points. That's why I made a script for it, to make it a little bit easier to check the different points, but it's still tricky. And this is just a tricky example. The good news is, like I said, these scripts don't have dependencies. So you can just download these scripts in the description if you've watched the video and kind of followed along, and then use them inside of your game and have at least a good understanding of how they work. So even though maybe you didn't write them all out and understand every little detail, you understand at a general level how they work and can use them based on that information. So hopefully you found this video helpful. I've got new videos on the way. If you like this video, be sure and give it a thumbs up and share it on Twitter or Facebook or wherever. Thank you guys so much for watching, and I will talk to you guys later.